appreciate. Our effort is organized under the banner of something called Engineering to Empower, and it arose out of our experiences in post-quake Haiti, and our setting is Leogane. So for those of you not familiar with Leogane, it is the home base for the Notre Dame Haiti program, as you may know. It's a town of about 130,000 people, and it was the effective epicenter for the 2010 earthquake. So while you might have heard a lot about Port-au-Prince, in terms of level of destruction, Leogane by far was the hardest hit community, with around 90% of its structures damaged, many of those collapsed. So imagine that degree of loss. You can see why it does eclipse what happened in Port-au-Prince by far. So today we're going to talk about how to do an empowerment model, as we call it, for sustainable reconstruction. And our focus here is on residential urban housing. The reason I want to focus on that problem in particular is because residential structures, no matter where you go in the world, you build your own house. You finance it, you supervise it to some extent, whether you hire someone or not to do it. It is your development. And that is not any different here in South Bend, Indiana, than it is in Leogane, Haiti, than it is in any of the other venues around the world. And so it's important to understand that this segment of reconstruction has been neglected in the plans for recovery. And it's for this reason that we became very passionate about addressing that issue. The backdrop for my talk is 4 trips to Haiti. Shortly after the earthquake, we began our work in March to look at what went wrong. And a lot went wrong in Leogane in particular. We went back in August of 2010 to then kind of figure out, well, how were people building pre-quake and how are they recovering now? And then we went back in March of 2011 to do a master planning workshop that I'll talk a little bit about, to look at how we could rebuild the town of Leogane in a thoughtful way. And we returned, as Steve mentioned, in December, to really start looking now at how we launch our initiative as Engineering to Empower to bring residential housing to the people who are being neglected, as I said, in the recovery plans. And so this is kind of the backdrop for my talk, and these are the experiences I'm going to reference as we talk about this. So this picture motivates what we believe in strongly as Engineering to Empower, or E2E. These are the conditions that weren't just present right after the quake, but even up to 2 years after the quake. Over 500,000 Haitians displaced in this earthquake, 4,700 families in Leogane living in these conditions, and many of those still 2 years after the quake. It's shocking. Imagine living in these conditions with heavy seasonal rains, hurricanes, the cholera outbreak, all of those conditions superimposed on losing all the infrastructure around you and being offered very little in the form of a legitimate pathway to rebuilding your home, not knowing how you're going to get out of this and get into something better. That's the motivation for our problem. That's how we address the needs of this community as part of Engineering to Empower. To explain to you why engineers didn't do a particularly good job responding to this disaster, I think it's important first to explain what we do after a disaster. A disaster hits, and I try to diagnose this in a 5-step process of what we do. We go in and first identify the hazard. What affected this community? Hurricane, earthquake, how big? Will it happen again? If so, when do we think it'll happen? How big? Understand the hazard. Then we assess the vulnerability. We do reconnaissance, we do forensics, we try to figure out what went wrong. And based on what went wrong, then we go and we try to refine the codes, the practices, the standards that exist in that nation or that city to help inform how to recover. And once we've done a lot of research on how to refine the existing practice, then we disseminate that information through the educational pipeline in that setting. We retrain the engineers, the construction teams. And then we get to the work of repairing, retrofitting, and rebuilding that damaged infrastructure. Now, what I want to point out is this is the approach that's applied all over the world, but there's a couple problems. First of all, it requires a government. You don't have codes and standards and inspection processes unless you have a government that imposes those. And it also presupposes that we have an educational pipeline present to train engineers in construction technology, people in construction technologies. And it also assumes that there's a thriving economy to support that reconstruction. Because while there's aid dollars, it's never enough to truly reconstruct and recover. And what happens as engineers, we go in assuming that these pillars are present. And when we get to a venue like Haiti where they're really not present, or maybe not to the level that we expect, we panic. We're type A personalities. So some of the best minds that came to look at Haiti in the reconnaissance and documenting what went wrong and what the hazards were, started to think, well, now how do we fix it? Because the rest of our pipeline we can't unfold. The last 3 steps we can't do because we don't have the underpinnings for that. And so a lot of the best minds walked away. And that's the shame of it. We didn't walk away. But we recognize there's a significant issue with that 5-step process that I just explained. That 5-step process targets the lowest hanging fruit. Let's fix what people are already doing. Let's tweak what they're already doing and re-implement, because that by far is the easiest thing to do. Here's an example of the danger of this lowest hanging fruit approach that engineers normally take. March 2010, that pile of rubble is a home, a fairly large home that's located near the Notre Dame residence. Came out, documented the failure there. You can see complete collapse. Went back out in our reconnaissance in August, and they were rebuilding. The mason had been retrained in France, had some new techniques he was applying, and they were reconstructing. Now, this is a wealthy family. They hired a crew to do this reconstruction. They have resources most Haitians do not have. But what was troubling was the false hope that was bred by this practice. They got a little bit of training in France, and they came back to re-implement with no oversight, no inspection process to make sure it was being done right. So he starts building. Now we say to him, okay, he's stacking the block. That's the common mode of construction in Haiti. And he admitted that when I get to the point of putting the next floor on the building, I'm not sure how to do it. How do I put a proper roof on that first floor that becomes the floor of the next floor? He wasn't sure how to do it, so he was kind of stalling his process. By the time we came back in December, they had gone up to a second floor in the same way they did pre-quake, because necessity drives you to just get it done. So it doesn't matter that you don't know the right way to do it, you're not sure it'll work. At some point, that family needs a home, and at some point, you're going to push the envelope and try to build that home in the same way that you did when it collapsed. The reality is that if we continue to promote this kind of practice by giving short duration training, make people think it's safe to do this, they'll keep doing it. The reality is that without quality control and inspection, it's difficult to do this safely. And the harsher reality is the majority of Haitians don't have the revenue, the income, to do it safely. So we think that this is kind of a dangerous way of breeding false hope and some unsustainable practices. So what's the alternative? Well, the alternative, some might say, is the need is so great. And trust me, my heart aches every time I'm there because I see the need. But the rush to meet that need at the expense of building long-term capacity is a true danger, because it creates perpetual dependence on aid. So yes, we could ship in houses from the States. We can ship in building materials from the States. Engineers, construction teams, we could do all that. And we could fix the problem tomorrow. But will we truly fix the problem? I doubt it. We'll perpetuate aid dependence for a country that already is dependent on aid for much of what it does on a daily basis. So how do we break that cycle? Well, our group contends that we can break this cycle. It's not easy, but it can be done. And it can be done in the domain of housing, something that, again, is personally developed by individual families, if we adopt something that we call an empowerment model. Now, our idea here is that in order for this to work, you've got to satisfy 4 tenets that support this model. And to go through those 4 tenets, you have to do a lot of time, spend a lot of time listening and thinking carefully about them. And so I'll spend a lot of my talk today talking to you about our experience of learning about these 4 tenets and understanding them in the context of Haiti to inform how we rebuild, in a process that unmistakably is long and tedious, but we trust is the right way to proceed. So the first tenet is the one engineers focus on the most. It's resiliency. How do we make sure this structure has life safety? It's not going to collapse again, and it can handle every disaster that country might face in the future. It really requires us as engineers to understand the hazards that face the people of Haiti and what they were doing in their previous practices that created vulnerabilities that were exploited in January of 2010. Well, in order to understand that, you have to understand the way that Haitians build, and that really depends on where they sit in the economic pyramid. The reality is that while there are houses made of organic materials like the one you see on the far left at the bottom of the pyramid, for most low-income families, their goal is to have a house made of block. Okay, block masonry, it's called CMU, a concrete masonry unit, is the building block, literally, of a modern urban home in Haiti. And so eventually, a family at the bottom of the pyramid may hope to build a block home with vented windows and a tin roof. And that would be their objective. The problem is that this home uses those blocks and columns made of reinforced concrete, it's concrete with steel embedded in it, to support the structure. If a family is more ambitious and has more resources, in the middle of the pyramid, they may take that same premise, make it a little bit bigger, but more importantly, put a concrete slab on the top as a roof, so that one day they can add a second floor and go up. These families are taking the same concept but now putting a heavy slab on top, so just keep that in mind. And at the top of the pyramid, families want to expand that to an even bigger home with more stories and a bigger, what we call, floor plan. But they're taking that same concept and stretching it out. That was very dangerous. So what ended up happening is we have this kind of solitary means of building. Concrete columns and concrete block. And that's it. Every house is built the same way. And now we're going to throw at that one mode of construction the two worst disasters we know of. We're going to put hurricanes and earthquakes right at it. What you do to design against an earthquake is in direct opposition to what you would do for a hurricane. So in Haiti, they saw hurricanes frequently. These heavy block houses did a really great job resisting those winds. When you throw an earthquake at a heavy house, it crumbles. Its demands are so high, you usually can't take them, and you need a family that's living like this now, on top of a pancake collapse. There's very few settings in the world where you have to design for both. Japan's one of them. We don't have Japan's economy to drive reconstruction in Haiti. So when you take a look at what went wrong, not to belabor the engineering part of this, the walls killed the people of Haiti, quite simply. The simple fact is that those heavy block walls split in this classic diagonal crack pattern, that X. And as soon as that X forms, the force jumps into that column. What you see bent there is the steel that essentially is holding that column together. And as soon as that happens, and that column is clipped, it's like taking your knees out from under you. You come down. That's what happened over and over and over. So the vulnerability is very easy to see. The walls ultimately killed the people of Haiti. So now that we understand what went wrong, well, now how do we find a solution that's feasible? Meaning it can be practically implemented with the existing technologies and materials that are available in country. You really have to understand the capacity constraints there. And that's where it becomes quite sobering. In a deforested island, we don't have wood to work with. And in a country whose economic condition and the high tax on imports makes it difficult to import in building materials from elsewhere, we don't have a whole lot to work with. So Haitians work with what they had at their disposal. Out in front of a home, you'll see a pile of larger rocks and smaller gravels or aggregates and sand, bags of cement from the DR, and those blocks that are used to make the walls, those CMUs, that are pressed by hand by somebody with a little manual press on a street corner. The concrete is mixed by shovel on the ground often, and that's how construction unfolds, so it's a very manual process. And only these materials are really readily available. Steel, which is absolutely essential to make concrete survive earthquakes, is in high demand and is very expensive. So it's used sparingly, and unfortunately that led to a lot of the problems we saw in the quake. Then you have to understand the construction practices in country and how necessity drove certain practices that, frankly, things had to get built, so you do what you can. Here's an example of how that created problems in Haiti. In a deforested island, you don't have a lot of wood to make the mold with which you cast concrete. Concrete requires something called formwork. It's a mold in which you cast concrete. You'll see it on the job sites all over here. When you don't have a lot of wood on the island, you need to find another way to cast those concrete columns or beams to build that house. So in Haiti, they do a kind of reverse process than what you might see in the US. They start by putting in a foundation, and coming out of that, you'll see steel. That's called a reinforcing cage. That comes out at every location where they're going to put a column to hold up that house. Then they lay the bricks for the walls, and you'll notice they leave the gap where that steel is residing. And then once the wall gets to its full height, they take whatever wood they can find, plank it on either side, and cast the concrete into it and make the concrete column. Those columns are the legs of the house that holds it up. They're essential. That process, which is driven by necessity, because there's not a lot of wood for formwork, implies that every leg, every column in a house is the same size. No matter if the house is 5 stories or 1 story. No matter how big it is, no matter how big the loads, they will always be the same size because they're driven by the width of that piece of block that they used to make that mold. The columns were dramatically undersized in most cases in Haiti. They were too small, but they were driven by this necessity. The other thing you have to understand is any environment where upfront financing for a home is not readily available, construction is progressive. You add a piece with time. Construction is very modular. And that means if money runs out, you just stop pouring concrete. Well, these discontinuities are also a very big source of vulnerability for engineers. So how do we rebuild in a way that's modular? People can do piece by piece, so it fits within that economic model, if you will, but still do it safely. It's a significant challenge. All right, so we understand how we have to build. We have some idea of the hazards we face and what the vulnerabilities were. Now, how do we do this in a sustainable way? And this is the one that usually gets you. How do we do this in a way that it only uses what's available locally and at a price point families can afford? That's a really tough thing. It has to understand the market. It gets into the financial piece. Well, the simple fact is, when you put economics on the table, it means there really aren't solutions at the bottom of the pyramid. So for the families with the least resources, which are a lot of families in places like Leogane, they don't really have choices. Because to fortify the old-fashioned masonry block construction that I showed pre-quake, houses would be $10,000, $20,000. And a family on $1 a day doesn't have that kind of money. So you can quickly see how sustainability kills most efforts to have a local solution. It just can't be afforded. So what happens to families? Well, families stay in the shelter they made by hand, or if they're lucky enough to get a T-shelter because they could prove they own the land they lived on, then they get to live this way for 2 years. And some of them realize they're going to live that way a lot longer. So they put an address on it, build a porch on it, and it starts to become permanent. They open a business in front of it. This is home now. So here's your reality. You either come up with that money, or you make temporary shelter permanent. And that's my fear, that this is what will happen to the folks at the bottom of the pyramid in Haiti. Okay, so now that we've painted this stark picture about the economics, there's one last factor. If the solution we propose is not culturally appropriate, then it won't be embraced. And let's be honest, for a family with limited resources who we're asking to come with us on the journey toward a new home, with that little bit of money they have left over every day, we better make it a home they're proud of, a home they'll want to live in, a home that meets all of their needs. And we can only do this by listening to what they need and what they expect in a home. So that requires a real appreciation of the cultural context. And that really means you have to provide a voice to the voiceless. And the real challenge that we saw is when we went into this master planning workshop last March, the town of Leogane came together to start giving its input into what they wanted the future of Leogane to look like, in dimensions that spanned education, healthcare, infrastructure, you name it. The problem was the people at the table were the leaders of Leogane. They were educated, they were motivated often, they were some of the wealthier folks in town, which is great, those are our leaders. But the problem is the displaced families weren't there. The voiceless didn't have a voice in the process of shaping what Leogane would look like in the future. So as we were running the housing portion of the workshop, we broke away from the workshop venue and went out into the camps. And by going out into the camps and taking time to listen to what people want, you realize quickly that the solutions being proposed by external entities are not what they want. They might be cost effective, they might lead to a quick recovery, but people don't want them. And they don't want to live in a multifamily apartment style structure that you might see in other urban zones around the world. They want a single-story home because they're afraid of the multi-story homes after what they saw. And many of them didn't own the land they were on, so how do you work within that land tenure issue? If you take time to listen, you learn quite quickly that a lot of the solutions on the table could have been knocked out immediately if they went out and listened to the voiceless, to the people who were supposed to be the recipients of these homes. And thanks to the support from Kellogg, our translators are continuing this work right now for us by talking to the families of Leogane who remain displaced, who are in those T-shelters. And this is Lamar, sitting with Dustin, doing some of those field interviews that we've been working on that we're now rolling out in a systematic way to give them a voice. So what you quickly learn is listening. Listening is so important. And if we listen across those 4 tenets of what it would take to make a house resilient, to make it feasible, to make it sustainable and viable, we start to see attributes. Attributes that can make a difference, that could be a game changer. And so listening becomes the first most important part of how we inform this empowerment model. And then once you listen, you need a way to evaluate. Not all solutions are going to work. Not all of them satisfy these requirements. So as part of our experience last March in the planning workshop, we started developing a rubric to evaluate solutions. We brainstormed on walls about attributes that would be favorable or that would be a way to measure satisfaction of those tenets. We sat with Haitians and had them weight what they thought was most important in that process and developed a rubric that allows objective scoring of different models. So this way, when you have something like the Building Back Better Expo, you could actually score the solutions presented to see if they truly are sustainable, and you'll find that most aren't. This gives us a framework to operate within so that we could present the results in the workshop. There's me doing that, and you can watch it on YouTube and you can laugh at me doing the bilingual presentation with my translator. But the point was it gave us a way to show what solutions are out there that would truly satisfy this empowerment model. Well, here's the problem with listening and evaluating. You don't always like the answer you hear. And the reality is the lowest hanging fruit, the one that would be easiest to implement again in Haiti, is that block. are those masonry blocks, the blocks that I told you kill. Because there is no other market solution out there. There's no competitor that can survive. The block is it. And so as a result, what do you say to families at the bottom of the pyramid? Once you run this analysis, you go, and the winner is the block that killed you. And here's your option. You either come up with the 20,000 or 10,000 to do it right, or you go to one of these two photos. You stay here indefinitely, or you just start stacking the blocks again and hope another quake doesn't come. That's the options we presented to people of Haiti, particularly those at the bottom of the economic pyramid. So we didn't like what we heard when we listened. And we decided that it's time to start innovating. It's time to introduce something new because what's on the table doesn't work. It doesn't work for the people at the bottom of the pyramid, and we shouldn't just listen to the people at the top. So the idea of innovation comes from looking at what the successes were. What did work? Well, you know what worked? The gingerbread houses worked. They didn't fall down. There's a picture of the classic gingerbread house, the colonial home that's built of wood in a frame with light panels or planks that are covering it. And there's the rubble of the modern home in front of it. This termite-infested gingerbread house that's seen how many hurricanes is standing, and our modern home is in rubble. What can we learn from the gingerbread house? The gingerbread house is light. The gingerbread house uses a frame like your human skeleton to hold it up. The skin, the outside, it's lightweight, and all it does is protect the inside. You don't need heavy, thick brick walls to survive in Haiti. You can survive in a lightweight wall. So the question became, well then how do we make a modern analog of the gingerbread house in an environment where we don't have wood anymore? And that led us to start looking at ways to make thin panels out of the materials that are locally available. And here's Dustin with Lamar and Edson showing a displaced Haitian a sample of that wall. And when they hold that in their hand, they see it as a possibility to rebuild in a new way. And they get excited about that possibility. An excitement that puts a lot of pressure on us because now we want to get down there and start rolling these out. So it's a real tough place to be as a faculty member when the rest of your daily life is right here. So now that we know a way to innovate, we still have to do it in a way that empowers. Because if I just collect money and ship a bunch of these down there and build them, that really doesn't help empower. So you listen, you innovate, now you empower. When you empower, you think to yourself, well, how do we do this in a way where there's no government oversight or building codes, no inspection process, no way to certify it's being done right? How do we get around that? And the reality is, when I take away all those bricks and I go to a skeleton model, then this better be a good skeleton. Just like the human body, it better be a good skeleton, or else it doesn't work. And by asking people to harness their limited resources in building a proper skeleton, or a frame as we call it in structural engineering, then it puts a lot of onus on that skeleton to be good. And so as a result, we had to come up with creative ways to help people build these skeletons that would achieve the quality control needed to do it safely. And if that frame is constructed, then families could progressively procure panels, these lightweight panels, to start hanging off that frame and finish the house. Put walls on the inside, walls on the outside, install the windows, the doors, the roof, in a progressive process. So it works within the way that people build their homes, modular, piece by piece, as money's available. Everything we did, from the way the frame's constructed to the way that it's finished by hanging the panels on it, is done so a family can buy it piece by piece as money becomes available, which is essential. Now, of course, coming up with the innovation is one thing, how you actually get it done is another. So the green box kind of summarizes that we had to come up with a whole framework to enable this to happen. The idea, the innovation, is nothing without the framework. So what does that mean? Well, in a country with no formwork, we have to provide reusable formwork for them to mold these concrete beams and columns to make that skeleton. We have to introduce mixers to properly mix the concrete so we get good quality. So to do this, we decided, well, why don't we have communal resources that people check out and use? The spirit of Convite, right? Using in the same idea of the co-op in the rural areas, bringing it to the city, we'll work together and share our resources to rebuild. And then we'll prefabricate all the components in a locally owned and operated depot so that we have control over the quality of the product. Everything from the steel going into the columns to those panels that you see there are all done in a quality controlled way by somebody who's skilled in doing that all day for a living. And they take pride in that work. And then we take the construction process and break it down in a way where we can train people on a particular skill set that they become certified in. And they can put up that house quickly, safely, and at a fraction of the cost of laying those bricks in the field. It's a dramatic game changer. And all it takes then is the implementation of it with the right partners. So ultimately, an empowerment model for post-quake reconstruction in Haiti is built on 4 very fundamental tenets. Sadly, there are tenants that I see many of the other solutions on the market not satisfying. And the danger to try to rush out and meet immediate needs, while it's a very real passion for all of us, we soon realize that that will never empower people to rebuild safely after the NGOs leave, after the aid pulls out. Only by addressing all four of these aspects and supporting a model for reconstruction can you do so in a meaningful way that could affect long-term change. And I hope today's brief presentation kind of summarizes our experience in Haiti in doing so. Moreover, I want to emphasize that solving this problem for the people of Haiti is really solving the problem for the poor of the world. The reality is there are millions, estimated 1 billion people living in urban slums around the world, in conditions where houses are built out of necessity with very little oversight and engineering. There are many silent Haitis waiting around the world for a disaster to strike them and show how vulnerable these practices are and how many people can be affected in just one instant, one earthquake, one disaster. So solving this problem for the people of Haiti, coming up with a sustainable, affordable model to achieve a real solution to the urban housing dilemma is a solution for millions around the world, not just for the people of Haiti. So many could benefit from this work. So I thank you for your attention and for listening to our story of how little by little, piece by piece, we want to help the people of Haiti to build a true nest that they can be proud of. And with that, I want to acknowledge so many people that are essential to this effort, from our sponsors, including Kellogg, who are helping us to do this work, to the E2E team, who's shown here, 4 of which are sitting right in the front row, Dustin and Ryan, Jackie, and Ben, as well as Alexandros Taplanides, my collaborator in the department, my fellow structural engineer, and many other undergraduates who contributed. I want to also thank Lamar and Jean Edson, who are doing the work on the ground for us to give a voice to the voiceless, to inform our model while we're still up here. And of course, the Nursing Haiti program. Thank you, especially Susan's here, for all the work that they've given to support our efforts on the ground. Without them, we could not do this work. And so with that, I thank you and welcome any questions.